Hey everyone, and welcome to Dr. Abu Artin Academy channel. Today we are going to discuss part 6 of the descriptive statistics and the subject of biostatistics. This video is one of the most important videos because it talks about the main topics in the biostatistics. And here in this video we are going to talk about describing the distributions with numbers, okay? And here in this regard we'll talk about the mean, the median, the quartile and interquartiles, the box plot or box and whiskers plots, okay? Also there is another name for it, box and whiskers plots, okay? So you can find this name, box and whisker plot or box plot, okay? Also we are going to discuss the standard deviations, okay? And we'll come to all these topics in detail. The way I'm preferring in this video to start giving you an idea about all of them, and then we'll see the slides, and if there is any additional data there in the slides, we'll come in touch. So most of the data, before going through the slides, we are going to discuss and take some examples on them, because I see the slides need some more clarity or more details. So I get some examples, external examples from the internet or from outside sources. So we can go through them and then we'll go through the slides. So here we'll start with discussing the mean or the arithmetic average, okay? It's called mean or average or arithmetic average. And this is one of the easiest and simplest topics which you have in this video. So in this example which is given here, we are going to discuss about the height of the woman, okay? And it is in inches, so no one will say that, okay, it is 58 centimeter. No, it's 58 inches. 1 inch equals 1 inch equal 2.54 centimeter, okay? So the height here, you can say it's almost in the average of around 160 centimeter, okay, which is reasonable height for the woman, okay? So here in this example, the heights are range starting from of the sample which has been selected in the example, starting from 58.2 up to 69.6 inches, okay? So if I want to describe this data, I cannot say that this the most of the women here in this sample is 58. I cannot say that they are 69. For example, if you have scored in some exams 80, some exams 80, 85, 82, 83, and some other exams you scored 90, 95, 92. I cannot say that, okay, your average or this students almost will get 90 or will get 80. I have to calculate the average or the mean of the scores or the grades which you have scored, okay? So I have to sum all of them and divide it by the number. And the same way which we are going to do here. So in order to get the average of all these heights, okay, so we have to sum all of them. So 58 plus 59 plus 60.7 plus 60.9 and so on until we reach 69.6. Then after summing all of them, if you sum them on the calculator, you will get sum. We'll call them x, okay? X is the height, okay? Height. Sum of x equals of all x's, x1, x2, x3, x4, and so on. So sometimes instead of writing x1 plus x2 plus x3 plus x4 and so on, you sum of xi, and I can be any value. So I starting from 1 up to, for example, up to 20. So sum of xi means every time I have to substitute I by one of these numbers. So the first time I substitute I with 1, so it would be x1 because it is sum, okay? So I have to write plus. Next time will be x2, x3, and so on until I reach x20. So this is starting point and this is the ending point until I reach plus dot x20, okay? So here I have to sum all the x's, sum x, I, where I start from 1 up to I20. Then I get all the or as given in this example, it will be 25. Okay, so here in this this column has 13 up to x 13 here, and another 13 here, so 26. One is empty, so it will be x 25. So I have from x1 up to x 25. So I write xi. So let us write it again. Okay, sum xi, where I starts from 1 and I ends by 25. Okay, so the sum of all these x's will equal x1 plus x2 plus x3 and so on, 1598.3 as listed in this table, divided n. Okay, so this is the sum of x's. Okay, this is the sum of x's. If I want to get the mean or the average, I have to divide this sum by n. So the mean or average or x bar, if the variable called x, so that its mean will called x bar. If the variable called z, its mean or average will called z bar. Okay, if it is called k, so the variable called k, k1, k2, k3, k4 and so on, so the average will called k bar. Okay, this called bar. So x bar will be the sum of xi, where I start from 1 up to 25 or up to n. Okay, in our case it is 25, divided 25, the number of them, divided n. Okay, divided n. So in this case, equals the sum of all of them, this plus this plus this plus this plus this, all of them will equal 1598.3 divided 25. So I get the average, which is in this case will be 63.9 inches. Okay, so I can, if I want to describe this sample, I can say I have a sample of women and their average height is 63.9 inch. That's why it was mentioning describing the distribution. So every time when we take the mean, the average, the median, the interquartile, the box plot or Whiskers plot, the standard deviation, we will know how to describe the distribution. So the mean or the arithmetic average, in simple or in short, it is the sum of all the numbers divided the count of the number. So the sum of x divided n, that's it. And the x here, it will be all x's. Okay, xi. As we can see in this example, okay, the arithmetic mean or the average, okay, of n numbers. For example, instead of x, it will be I'll have a, so a1 instead of x, and the x bar will have a and the a bar. Okay, instead of x1, x2, I have a1 and a2 and so on. Okay, so here I have a1, a2, a3, a4 up to an. So the average or arithmetic mean, a bar, because it is a not x, so I cannot write x bar, I have to write a bar. Okay, equals the sum of them, a1 plus a2 up to an, divided the n number, the last one. Okay, 1, 2, 1, 2, 3 up to n, so divided by n. The example here which were given, I have numbers of 2, 5, 4, 1, 2, 3. Okay, so the count are 6 numbers, 1, 2, 3, 4, 5, 6 numbers. So I have to sum all of them. Okay, sum a. Okay, I can say from I equals 1 up to 6. Okay, so it will be a1, a2, a3, a1, a2, a3 up to a6. Okay, up to a6 in this case. So it will be 2 plus 5 plus 4 plus 3, okay, all of them together, the sum of all of them, divided their count, 1, 2, 3, 4, 5, 6. Okay, it will be, the sum of these will be 17, and the count of them will be 6, so this is the average number. In this example also, I have here 12 numbers, 1, 2, 3, 4, 5, 6, and 6 down. So total are 12 numbers. So n equals 12. What is the sum of the numbers? So I have to sum 90 plus 77 plus 94 plus everyone plus each other. Okay, until we finish all of them. So the sample mean or the average will be the sum of all values of the sample divided the number of the values, the count, okay? Sum x divided n, okay? So sum x will be 90 plus 77 plus, so that will end up with 1170 divided 12. So this will be the average or the mean, okay? So I think that the mean now is very clear and we don't have any doubt how to calculate or to have arithmetic average or to calculate the mean of any sample which we have. The next slide also talks about the same thing which we have reviewed now, and it's x bar if we have the sample x, okay? So x bars mean the average, okay, or the mean x bar. Here x1 plus x2 plus x3 up to xn. So we can call it, okay, let us just clear this one and write it here. So it will be equals to x1 plus x2 sum of xi. So what is I? Is it n or no? It starts from I equals 1 up to I equals n. So this is the sum. This is the numerator, okay? The sum of them. What about divided? Divided n. So we can write it in this way. Sometimes they get this n outside and say, okay, 1 divided n times the sum of xi or sum of x, okay? If you, for simplicity, you can ignore I equals 1 and I and n because you know that you will start from the starting point from the x1 and you will end up with the last item in the sample which you have. Okay, so also you can ignore this one. So you can write it in this way. Equals sum of x divided n. That's it. Or 1 divided n multiply sum of x. Okay, as we have here. Okay, 1 divided n multiply sum of x, but here just to put starting from I equals 1 up to n because xi. Okay, here if you look at the sample, I have here the woman, I have the first sample 1, I1, I2, I3, I4 and so on. Okay, so we can calculate of them up to 25. This is the example which we have taken. So how many the count which I have here from 1 up to 25, so n equals 25 and the sum here is 1598.3. So I have to divide the sum. Okay, the sum of all x's, sum of x equals 1598.3, okay, divided 25, so I get the average. This is the example which we just answered in the previous slide. In this slide, they are talking about the numerical summary and whether it is meaningful or no. It has meaning or no meaning. Some of the sample, when we have the reading or the measurement, it gives us meaning. It is very clear and easy and normal or regular, so we can easily describe it. And some of them are very complicated and sometimes they don't have any meaning, so we have to find different way how to represent this data. So in this example, in the first example which we have here, okay, we have histogram, and in this histogram, this is about the same example which we have taken for the height of the woman in the previous slide. If we look at it here, so it looks like normal a little bit. It looks like normal, okay? So we can say it is fairly or approximately it is normal one or regular one. So here the distribution of the woman height which we took in the previous slide appears coherent with each other. So it is consistent, coherent, matching with symmetrical, okay? It is not something which is odd or unusual, irregular, okay? It is coherent. This means that the mean which we have, if we get the mean of it, the mean is a good numerical symmetry. I don't want to deviate from the purpose of this slide, but just two things, because this is a histogram. In the histogram, as you can see here, we have the height of the ladies, which is starting from 58 up to 70. Okay, and within this range, we have the number of individuals. If you look at the range of 62 to 64, we have the maximum number of people here, individuals, okay? So we have here 4, okay, within this 2 range. So the most of the people are falling with this range, the 2 highest one. That's why if you remember in the high school or in the secondary school, we have something which called the mode. You remember the mode? Yeah, the mode is the number which is repeating mostly. Okay, so I have 3, for example, 3, 4, 4, 4, 5, 7. So which number repeated mostly? 4, repeated 3 times. So in this case, my mode will be 4, the most number repeated or occurred many times, the most of the times, okay? Here also, which numbers are occurred most of the time? The range of 60 to 64, this is the most one occurs. So here you can find the modes of the histogram. So the mode of the histogram, it is within these 2 bars, okay? So from the graph itself, from the histogram, from the first look, I can say, okay, so the mode of, if I want to describe in 1 second, I want to describe the sample, I can say, okay, most of the ladies here are within 62 to 64, because this is the mode of them, okay? Then I can look at the mean, their mean. Their mean is 69.3, okay? The mean of them. So I can also describe the mean. So I can describe them also using the mean. But if we look at some other graphs, because the graphs are not usually regular like this one. This one is the regular, we can refer to it. But if we look at this graph, this is the height of all plants, okay? And this is the number of plants. We can see here there is inconsistency or incoherent. They're not matching. We cannot say that, okay, they are normally distributed. The shape is not regular one. It is irregular shape, okay? But we can split it in 2 parts. But if we don't want to split it in 2 parts, so here we can say, okay, this part has distribution, this part. So I have more than one distribution within it. So this is overall, it is irregular shape, okay? So we can say here, this one is a regular shape. We can describe it. We can use the mean or the average for this sample, okay, to give a meaningful description or summary, okay? But this one we cannot, because you have different type of plant. Here, the shape of the distribution is widely irregular. You have different shape. You can have different shapes of the distributions here and there and everywhere, okay? So in this case, we might end up, okay, it is a regular distribution, but why? Why it is irregular? Why here it was regular in the first example, in the above example here? This one is regular, and why this one is not regular? Because this one is the sample of a woman from the same species. All of them are women. Maybe even they are from the same area, from the same country, playing in the same club, or they're educating or getting education in the same school, okay? So all of them are within a coherent range, okay? So we can say that we can get the mean of them. But these plants they may came from different area or from different country, even from different continent. So some of them will be 1 meter high, some of them will be 10 centimeter or 5 centimeter. Some of them will be 99, some of them will be 1.2 centimeter. So for plants, we cannot assure that the data will be coherent, okay? So here the shape of the distribution is widely irregular. If he asks me why, I can say maybe these plants are not the same type of plants. For example, if I'm measuring the corn plant, I may have a coherent shape, symmetrical shape. But if I'm measuring flour with corn, with wheat, with different plants, so definitely I'll have different heights, okay? So here I could give justification that they could have more than one plant species or one phenotype. That's why the data is inconsistent. I get strange plant together and I'm trying to make statistics for them. As we can see here in the next slide, which is talking about the plant. So here, this is different plant, this is another plant, and this is different plant. So each one of them will have different distribution, okay? So if I want to, or I'm trying to have single numerical summary here or single conclusion from all these different strange data, it will be meaningless, okay? It will not make any sense. So I have to split them into groups. Then I can have summary. Summary means conclusion or useful data or useful advice on them or useful explanation, description, okay? So here I cannot make numerical summary because they are coming from different species or from different area. Even you can see here in the photos of the plants. Now, and before moving to the next slide, here in the list of the objectives of this file, we have the mean, we have the median, quartile, and box plot or Whiskers plot, then standard deviation. But actually the slides which we have here in the PDF file of University of Debrecen, it is not fully covering this point. So some of them are covered and some of them are not covered, like the median was not addressed. For example, maybe because they expected that students have studied this in the high school. So I prefer to give some more examples. So I'll give one common example for the median, quartile, and box plot, so it will make our life easy when we go through the slides of the university. So in this example, which is just I got to get the three items together, we have an owner of a restaurant want to find out more about where his patron, he has some delivery motorcycles which deliver the food to his customers, and he want to check how far are the distances usually they are dropping the food to, or he's planning to have a delivery team. So he had a survey with his customers who are coming to his restaurants from where they are coming and how long they are driving, how far they are from his restaurant. So one day he decided to gather the data about the distances in miles that people commuted. Commuted means like transportation, moving, okay? To get his restaurant. People reported the following distance. Some of them said, okay, I have to drive or to commute 14 miles to arrive to his restaurant, 6 miles, 3 miles, 2 miles, 4 miles, 15 miles, 11 miles, 8, 1 mile, and so on, up to 20 miles, okay? He wants to create a graph that helps him to understand the spread of the distance, whether this distance are spread, most of them in one area, or are in scattered area. The majority of his customers coming 20 miles away, or coming 1 mile away, or majority of them, and what is the percentage of the people coming from nearby distance, and what is the percentage for the customers coming from very far away distance, how the spread out of his customers, okay, with respect to the distance, okay. So he want to understand the spread of the distances and the median, okay. He want the median distance, okay, that the people travels. What kind of graph should he create? We could have histogram, but because he talks about the median, histogram, it's not from the first spot helps him to get the median. But if he talks about the median specifically, this means that merely his focus is on box plot and whiskers plots, okay? So here his focus is on box and whiskers plot, okay. This, and within this example we'll know the median because we have to find the median, okay. So we know the median, we'll know the interquartiles, okay, or the quartiles, and also we will know the box and whiskers. So the three elements which we just talked about, we'll find them here in this example. So why this called box and whiskers? Box means I have one box and I have some whiskers here. So this whiskers, the word whisker means the beard. If you have a beard, the beard, the hair, one hair, okay? It's like the hair, very small, very thin hair, okay? So I have a big box and I have two hairs, one hair from here and one hair from here, okay? So that's why it's called whisker. So box and whisker plot. So the way we can plot this box and whisker like this, just have a box, okay? Then we'll have, we'll have one whisker here and another whisker this side. Okay, another whisker this side. Then the thing which we have to remember that it must be available on this box and the whisker plots. I must have the median. Median must be here, okay, inside the box. Could be in this place, could be here, anywhere, but it is one median inside the box, okay. So this median, as per the definition of the median, if you remember from the high school, to get the median we used to arrange as you recall from the high school or from the secondary school, in order to get the median, we used to arrange the data in order, ascending order, like 1, 2, 3, 4, and so on. Arrange them and then see the number in the middle, okay? So for example, I have from 1 to 7, 1, 2, 3, 4, 5. Let me erase this one so I have a clear. Okay. 4, 5, 6, and 7. So I have 7 number. If I picked 4, I took 4 here. So 4 is the middle number, because before the 4 I have three numbers, 1, 2, 3, and after it I have only 3 also. Okay, 1, 2, 3. So the count of the numbers or the elements or the measurement or the readings after the median equals to the count of the readings before the median. So I have here 3 numbers, 1, 2, 3, and I have also here 1, 2, 3. So 3 before and 3 after. So this is called the median. So the median means the number in the middle, in the center, where the count of numbers before it equals the count of number after it. It is not the mean. Mean, the sum of x's divided n, but median means just count. If I arrange them, put them in ascending or descending order, so the middle number means the number in the middle, the count of the number before it equals the count of the number after it. So, for example, if I want to get the median, okay, of the blue two examples, so I have to count them. First of all, I have to make sure that they are in order. If they are not in order, for example, if they are 1, 9, 8, 3, 5, 6, 11, so I have to rearrange them and put them in order from the smallest to the biggest, or the biggest to smallest, okay, ascending or descending. So if I arrange them, it will be 1, 3, 5, 6, 8, 9, and 11, from the smallest to the biggest, okay, in ascending order. Okay. Then, after making sure that they are in order, I have to count them, how many they are. Okay, let us see. So here, 1, 2, 3, 4, 5, 6, and 7. So I have 7 numbers. If I have odd number 7, I cannot say 7 divided 2, because it will give me 3.5. Usually, I want to see which term it will be the median. The first term, or second term, or third, or fourth, or fifth, or seventh, or sixth, or 7, or whatever. Okay, so I have 7. If I divided 7 by 2, I will not get the whole integer, a whole number. Okay, so what I do, if it is odd number, I'll add 1 to it, just 1 divided 2. So it is 7, I'll add 1, so 8. 8 divided 2, because it's 7, just I add 1, 8, so I'll get 4. So it will be the fourth term. This is the term which it will be the median. So here I go the first term, second term, third term, fourth term. So this is the fourth term. Okay, let me get another color so it will be visible. So the first term, second term, third term, fourth term. Okay, because this equals 4. So it will be, 6 will be the median number. So again, if it is odd number, for example 7, the count of them are 7, 1, 2, 3, 4, 5, 6, 7. 7, just add 1 to convert it into even number, add 1, divide, so it will be 8 divided 2 equals 4. So the first term will be the answer, okay, it will be the median. So I have to get the first term, this is the median number, so the first term, this is the fourth term. So 6 will be the median. So what if they are even numbers? So here in the second example, I have 1, 3, 4, they are in order. First thing, I have to make sure that they are in order. If we did not put them in order, our answer will not be correct. So 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 number already. So how can I get the median? Actually, this is the way I prefer to memorize it. This is my own way. If you don't like it, you can use your own way. So if they are odd number, I just add 1, like the example of the 7. 7 plus 1 equals 8, divided 2 equals 4. That's it. If they are odd number, okay? If they are even number, like this one, just here I have 8, the count of them are 8, so just divide the 8 by 2, it will give you 4. Then, because if it is even number, I will not have 1 point, I will have 2 points as the median, okay? So I divide the 8, the total number of them, the count of them, 8 divided 2 equals 4, so 4 and the next one. So after getting 4, I add 1 to the answer, not 1 to the 7, like here, 7 plus 1 divided 2, no. After getting the answer, I'll add 1, so it will be the fourth term and the fifth term, okay? So my answer will be the fourth term, but because I know that there are 2 terms, so it will be the next one also. So fourth and fifth. So here in this case, it will be the fourth and the fifth term. These two together. Okay. So now let us see. In the case of odd number and the case of the even number, when we say that, okay, the first term, we said 7 plus 1 divided 2 equal 4. So we said the first term, this is the first term. So let us count how many terms before it. 1, 2, 3. How many terms after it? 1, 2, 3. So also here, in the case of the even number, so even number which is 8 divided 2 equals 4. 4 and the next one which is 5. So the 4 and the fifth, the fourth and the fifth term, they are the median. So before them, how many terms I have? 1, 2, 3, and after them 1, 2, 3. So the number of terms before and after are the same. So what is my median? It will be the average of these two numbers, which is 5 plus 6 divided 2. It will not be 5, it will not be 6, it will be something in the middle, in between. So it will be 5 plus 6 equals 11, plus 2 equals 5.5. So this will be my median. I hope that the median is clear in this case, and we will come in touch with it in the example itself. So in this example, in order to get the median, we have to arrange this number. First of all, we have to look at them. Are they arranged in ascending or descending order? No. 14, then 6, then 3, then 2, then 4, then 15, again 11. So they are not arranged. I have to put them in order. So I have, in order to make sure that I did not miss in one, the number which I pick, I have to strike it through. So I make sure that I will not repeat it and I will not miss it, okay? So here, first one, 1. I cross it. 1 again, here. Then 2, and so on, until I arrange all of them. So I put them in order. Then I have to count them, how many they are. So I counted them, I found they are 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Sometimes they give me the number of the sample here in the question itself. So here there are 17. 17 odd or even odd. So I cannot divide, so I say 17 plus 1 equals 18 divided 2 equals 9. So the term number 9, after ascending them, it will be my median. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the median. 6 will be the median. So now I got the median, which is 6, okay? So the median is split the sample into 2 halves. So they are 17 number. If I take the median out of them, so we'll have 8 before and 8 after. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. And the same thing after. 1, 2, 3, 4, 5, 6, 7, and 8. Then I will take the 8 before. I will not consider the median again. So the median already fixed as a median. So I'll count the number before the median. How many numbers? 8. If I want to split them to get the median of the first part, which is on the left side of the median. So here I have to get the side on the left on the median, and also I'll get the median of the side which is on the right of the median. Excluding, I have to remove or exclude the median, so I will not count it, okay? I have 8 before it and 8 after it. So if I want to get the median of these 8 numbers, 8, it is even number, so I should not add anything. 8 divided 2 equals 4. Because it is even, it will have two medians, okay? I know that 2 items, 2 terms will be the median. So 8 divided equal 4. So 4 and next one will be 5. So the fourth and the fifth. So let us count fourth and fifth. 1, 2, 3, 4, and 5. So these are the median for the left side. These are the median for the left side. So the term number 4 and the term number 5, which is 2 and 3, will be the median. So the median here will be 2 plus 3, the average of them, divided 2, which is 2.5. Okay? 2.5. So this is the median of this side. So let us look at the right side as well. I want also for these 8 numbers, I want to get the median of them. Okay? So the first of all, I get the median of the whole sample. Okay? The median of the whole sample, which is 6. Then I got the median of the left side and then the median of the right side. So in the same way, I have also 8 numbers on the right side. So 8 divided 2 equals 4. So 4 and next one, the 5. So I have the fourth and the fifth term will be my mean. So here I leave them because these are the 8 numbers, okay? The 6 are not included. These are the 8 number 1, 2, 3, 4, 5, 6, 7, 8. So I have to get the fourth and the fifth term, okay? 1, 2, 3, 4, and 5. So these are the new median. These two will consist or will represent the new median. So 11 plus 14, the average of them, divided 2, 25, divided 2 equals 12.5. So my median is 12.5 for this right side. So maybe someone will ask why you are doing this, why you get the median and then get the median of the left side and the median of the right side. I'll tell him, okay, let us assume this is the timeline or the representation of my sample. If I get the median here, so this is the half, this is the median, okay? And this is the median of the median. If I split this one into 2, it's not 2 equal halves, but I'm telling you it is 2. If I split in 2, so this will be 1 quarter and this another quarter, okay? So first quarter, second quarter. Here, if we split this one also, it will be the third quarter and the fourth quarter. So they are calling it first quartile, second quartile, fourth quartile. Okay? So this is the median. Okay? This we'll call first quartile. Okay, and this is the median, the second quartile. So here this is the start, first quartile, second quartile. So this one will call third quartile or quartile, and this will be the fourth quartile. That's called 4Q, 3Q. So now we can write it in this way. We can write it here. This is Q1, this point Q1, we reach Q1. This is Q2, second quartile. Q3, this is Q4. Some people are writing it 1Q, 2Q, 3Q, fourth quartile, 4Q. So first quartile, second quartile, fourth quartile. Okay, so we can use the upper one, which is more usual. Okay, so first quartile, second quartile, third quartile, and the fourth. The second quartile, this is the median. This is the median. Okay, so this is the median. So now we knew the median. We have got it for the whole sample. Okay, and we get the median for the left side, the median for the left side, for the right side. So we knew and just the median. Now also we knew the first quartile, the second quartile, the third quartile, and the fourth quartile. So the last thing which we have here in the 3 items is the box plot and whiskers. So we have here, this is the start point, the 0, and this is the first quartile, the second quartile, the third quartile, and fourth. Second quartile here is the median. So how can I represent or draw this box plot or box and whisker plot? The whisker and the box plot and whiskers, they are represented by a box from the first quartile to the third quartile. So I have to draw a box starting from the first quartile here up to the third quartile. So here. So this is the box from the first quartile to the third quartile. Okay, And then I have the whiskers, the hair, the small one, the hair or the whiskers, from here up to the start, and from here up to the start. Okay, so this is the way. So this box starting from the first quartile and then the third quartile, and in between I have the median. Okay, it is not mandatory that the median every time will be in the center. Maybe it will come here next time or come here next time. It depends on the location of this Q. Maybe Q will be here, maybe Q will be, second quartile will be here. So it depends on it. But this is the way how we are presenting it. Okay, so the box will have 3 lines. The first line is the first quartile, the last line is the third quartile, and this is the box. Okay, so this is the box. And let us just use a different color of it. Okay, this is the box, and inside the box we have a line. This line is the median. Okay, so the start is Q first quartile, the end is third quartile, and in between the median. And here this is the start of the whisker. Okay, the beginning, and this is the end. So let us look at this example which we have here. In this example, just we came at this is Q3 or third Q, and this is first Q. Okay, and this is the median. We came here and just we draw a box from the first quartile to the third quartile, and here the whiskers. Okay, that's it. So how we can represent this data into box plot and whiskers plots? Okay, box and whiskers plot. Okay, so the first thing I have to find the first quartile, which I have here. I have already calculated it. These are the two. So it is 1Q or Q1 is 2.5. Okay, 3Q is 12.5, which I have here. Okay, so this is Q1 or 1Q, and this is Q3. These are the start and ending point. Okay, so I have to have here 1Q, 3Q, 1Q equals 2.5, 3Q equals 12.5, and median equals 6. Okay, so I come here at 2.5, which is almost middle here, middle of this one. You can say 2.5 here, this one 2.5, and this one we can say 12.5 here. Okay, 12.5. So I can come here above the 2.5 and draw a line, and above 12.5 draw a line. So this is 1Q and this is 3Q. Okay, then I'll draw a hair or whiskers till the start, the 0 here, opposite to the 0 here. Okay, up to the 0. So let me delete this one. So here up to the 0. Okay, and then another whisker up to the end. So here, sorry, my start point is 1, not 0. Okay, I have to draw this one up to 1 only. Okay, so up to here, for example, up to here. Okay, and from the other side, I have to draw the whisker up to 22. Okay, up to 22. So here 20, 22, up to here, almost up to here. So I have to draw the whisker up to here. Okay, so this is fourth Q4. Okay, so where is the median of the full sample? At 6. So 6 is here, so it will be here. So this is the shape. So this is the whisker which I have. So this is my whisker. Okay, box and whisker is here. This is the box and whisker plot, and this Q1 and Q3. So if I look at the whisker here, see the sample started from 22, but the median did not come in the middle. So here I may assume, or in my mind, that okay, the median should be here, something in 12 point something, but I find the median is here at 6. This means that Median means, if you remember, I have the number of counts before it equals the number of counts. So I have here 8 numbers before the median and 8 number after the median. This means that I have 8 number of the sample are coming from a distance, okay, the distance in mile, 6 kilometer, okay. So half of the people are coming from a distance which is 6 kilometer, okay, and the other half coming between 6 up to 22, okay. So half of the people are coming from a distance of 6 miles, sorry, not kilometers, 6 miles, okay, half of them, because this is the median. Median means the number on the left equals the number of the side. So I have here 8 people coming from a distance less than 6 or equal to 6, and here the other 8 people, the half, so 50% of the people coming from a distance so which is less than 6 miles, okay. So here it gives me indication about the sample which I have. If I didn't have this box and whiskers plot, I would have said that, okay, I have half of the people coming from a distance of 12 or 11, because here starting from 1 and then by 22. So I can say 21 plus 1 equals 23 divided 2 equals 11.5. So I can say half of the people are coming distance 11.5 kilometer and half of the people come. But in reality, it is not. In reality, half of the people are coming from a distance 6, because this is what the median shows. Median shows that the number of people on the left equals the number of the people on the right, okay? The number of the reading or the measurement or the sample or the individuals on the left equals the number of individuals on the right, okay? So this means if I find the median, the number here, so the median at 6. So this is the distance. So the distance 6, I have half of the people coming from distance which is less than 6 and half of the people come from distance which is more than 6. And this whisker called whisker or tail or skew. If you remember, we have taken the skew in the previous video. So the skew or the tail of the plot. I can also say that I have 1/4 of the people are coming from distance which is less than 1 kilometer, okay. Also, I can say that I have 1/4 between third quartile and fourth quartile, 1/4 of the people coming from a distance which is 12.5. This was 12.5 up to 22. Okay, so these people are spread. The same number of people. So here you have the same number of 4 people coming within the distance of 1 kilometer. But here also 4 people, because this is 1/4. You remember we said here 8 people on the left, 8 people on the side. So this is half of the half, which is a quarter. Okay, so 4 people coming from a distance between 12.5 up to 22 within a range of 10 kilometer, almost 10 or 9.5 kilometer. So these people are spread, widely spread. But these people, you can say the 4 people are only within 1 kilometer. If I'm planning to supply to the people to help them to have more customer, I can have a motorcycle here to serve this area. So if I want to serve one of these 2 areas, either this one or this one, which one I should serve? I should focus on this area. Why? Because it is only a distance of 1 kilometer. So the motorcyclist, he will not take long time. He can deliver the food and he can come fast. He will not consume petrol. The consumption of the petrol and even the cost will be less, and I'll serve 4 number of people. This is in the sample, but in reality, if you apply this sample to the population, maybe this 4 will represent 400 people. Okay, so he will serve the same number of the 4 people. But if I bought the motorcyclist to serve this area, he will serve 4 people also. So here 4 people and here 4 people, but he has to travel a distance of around 10 miles or 9.5 miles. The difference between 22, the difference between 22 and 12.5, which is 9.5 miles to serve 4 people. While I can put him here, he will serve the same number of people within 1 kilometer. So I can give the priority. So here the distribution help us to take decision and decide, okay, based on the histogram or based on the box and whiskers plot. It can help me to arrive to a conclusion or a decision. So by completing this video, we have now learned the mean, the median, quartile, and the box plot or box and whiskers plots. We have already completed all of them in one example. So we have the standard deviation, but because of the size of the video, I'll split it into two so we can continue the standard deviation in the next video.